Okay, the most basic logarithmic equation we could have is something like this. I mean, this is obviously simple, but and the M and the C, those are just kind of made up letters there. What I mean is, I have this expression in the logarithm, and it equals, in most cases, it's going to equal a number over there, but I'm calling it C. But I want to show you the basic technique with this and talk about that first, and then we'll apply it in an actual equation solving. What we're going to do here, in a sense, when we were solving the exponential equations, where we had different bases on both sides, in a sense what we did is we took and we LN'd both sides. So we had an exponential equation and we took the logarithm of both sides, which was the inverse operation, right? Logarithm and exponentials are the inverse of one another. Well, that's essentially what we're going to do here. We've got a logarithm, and so I'm going to do the exponential thing to it. But here's what it looks like, just to show you. What we're going to utilize is a property that we talked about last time, and that was, help me remember here, if I have a to the log base a of x, what happens there? Well, those, again, are inverse. They cancel out, don't they? The a to the log base a, those things cancel out. And so that simplifies just to be x. Well, I'm going to use the same sort of property here on an equation. It's called exponentiate both sides. So that's a new word there. Exponentiate both sides. And in this case, we've got base a, so I'm going to exponentiate both sides to base a. And here's what that means. Basically what it means is I want to make both of these sides be powers, if you will. And the base, they're going to be the powers, and the base is going to be the a. So that's what I mean by exponentiate both sides to base a, is make this a to the log base a of m, and then a to the c, okay? So you see I did the same thing to both sides. Both of them went to a to that equals a to that, right? Well, the beauty of that is, well, this side, by that property we talked about, the a and the base, the log base a cancels out, and so we wind up with this, which really doesn't, since we just have all letters, doesn't make probably a whole lot of more sense. But anyway, that's the technique that we'll utilize here. Exponentiate both sides, okay? And you fairly easy to see that gets rid of the logarithm. Okay, so that's the idea. All right, so how do we apply that? Say I have the log base 2 of 3x minus 8 equals 4. Yeah. Log base 2 of 3x minus 8. So I'm trying to solve this for x. It's a log equation, and so typically this is the technique, exponentiate both sides. And so in this case I do have a number for the base 2, and so I'm going to exponentiate both sides to base 2. In other words, this is going to be 2 to the log base 2 of 3x minus 8. So take this side to base 2, and then this side is exponentiated, so it would be 2 to the 4. Okay? So see why I did 2? Because that's the base. That's where I picked that number out from. Well, again, by that cancellation property, if you will, the 2 and the log base 2 over here cancel one another out and just leave me 3x minus 8 equals, and then 2 to the 4th, well, does it cancel there? Yeah, that's just 16. Just raise 2 to that 4th power, and voila, what we have is a nice little linear equation in this case. Easy to solve. Add the a divided by the 3. Now there is a little catch here. Sometimes that answer may not be the answer. It may not work, okay? So here's, on these logarithm equations, it's important that you check to see if this actually works in the original equation. In other words, what I'm saying is, go back to the original logarithms, because remember with logarithms, we can't do the logarithms of what? 0 or negatives, right? So really what we're checking to see, see if it gives you a log of a negative or log of 0. Because if it does, if it gives you a log of negative or 0, you got to throw that out. Because you can't have the log of negatives or log of 0. So if I plug in 8 there, does that give me the log of a negative? 24 minus 8, no, that's going to be okay, isn't it? That gives me the log of 16, which is okay. And so we're good. It'll work. That's what you're looking for. Okay? You have to check those logarithm answers. All right. One more quick one here, and then we'll talk about some. Okay, log base 9 of 7t, that equals 3. All right, so again, we'll exponentiate both sides. So in this case, it's base 9, so I'm going to exponentiate both sides to base 9. The 9 log base 9 clears it out on this side to be just 7t, and then 9 cubed, 729?
Yes.
Yeah. Divide by 7, then with the resulting equation, so
104.14.
104.14, approximately 2 places, how many places at once, but and then checking to see if I plug that in, does that give me the log of a negative? And that's clearly not going to give me the log of a negative, so it's okay. So they would probably give that answer if it rounded. If they want you to round it, go there. Okay? Okay, let me check. All right. Now, just a couple of little quirks that could come along here. As you know, that could happen. Okay, so 5 times log of 2x plus 700 equals 15. That's the next one. Okay, so here we have, the problem is that I have a number in front of our logarithm. And I guess there's a couple ways we could go with this, but the easiest thing to do here is I need that 5 to kind of go away or go somewhere else. Yeah, so what am I going to do? Divide it. Yeah, I'm going to divide off that 5, first of all here, because this technique we're talking about, exponentiate, only works if I don't have a number here, the number is 1. So yeah, divide off that 5, first thing. All right, now, second thing comes up here is the base is not showing up here. I don't have a base showing up. And so that's where you have to remember, if I have LOG with no base, what base is it?
10.
That's base 10. That's understood to be base 10. And so I'm going to exponentiate both sides, in this case, to base 10. And that'll get my cancellation like I want. But I have to do it to both sides. So exponentiate both sides to base 10. Yeah, then the log cancels with that 10 base. So this side is just 2x plus 700, and that equals 1,000. And then I'll just solve. Subtract 700, 2x equals 300, so it looks like divide by 2, x is 150. But before I say, okay, that's the answer, does it check out? If I plug in x to be 150 there, do I get the log of a negative or log of 0? 2 times, so that'd be 300 plus 700, that's 1,000, that's okay. As long as it's not a log of a negative or 0, it's okay. Usually the way it works, okay? Checks out. All right, any questions or concerns? Okay? All right. Well, a couple more here. Things we'd like for you to take a look at. All right, so 7 plus 2 ln 5x equals 18. All right, very similarly to previous there, for this exponentiate both sides to work, I just want the logarithm by itself. I need to isolate that logarithm, get that logarithm by itself for this to work. All right. Well, I need to get rid of the 7 and the 2 then, basically what that means. And so how do I get rid of the 7 and the 2? Well, to get rid of the 7, subtract it. Subtract both sides 7. That'll leave me ln of 5x, 2 ln of 5x on the left side, 11 on the right side. And then again, we've got the 2 in the front. That's 2 times it, so divide by the 2. Get rid of the 2. And you can leave 11 halves, 5.5, maybe a little easier to handle what comes next. So it's okay. All right, now we've got the logarithm, but it's an ln, and so what base is that? That's base e. Yeah, the natural logarithm, that's base e. And so I'm going to exponentiate both sides to base e. So e to the ln of 5x, what you have to do for this side too, e to the 5.5. Yes? Then the e l to the ln, that part basically cancels one another out. So we have 5x equals e to the 5.5. I'll leave it there, we can round it. But don't want to round too much on these in the interim steps, so let's just go ahead and leave it. So divide by the 5, and x is, whatever that,
48.93.
48.93?
494 if you round it.
48.94. 2 places. How many ever at once, but 2938, 38, yeah, blah, blah, blah. So yeah, you can round it off however they want you to there.
What's that squiggle above the equal sign for?
It's approximately. That one's not approximately. Yeah, if I cut it off there, wherever, that means approximately, yeah. Okay. Anything else on that? Look okay? All right. Now, last few have another wrinkle or two in them. Let's look at that. How about log base 5? Well, I didn't check that one, but that one's clearly going to be okay, isn't it? 48.9 about, that's going to be okay. This one, I think, we might run into a slight problem with one of the answers anyway. All right, let's say we got log base 5 of x plus 24 plus log base 5 of x equal 2. This will be the one, next one we try out. Well, problem do we have here? The problem we have here is we have two logarithms, not just a single logarithm. And so the exponentiate both sides technique won't work because we have two logarithms. You need only one logarithm for that little thing to work. And so hopefully there you're thinking, I need to combine those into one logarithm. So here's where our condensing properties will come in handy. How could I combine these logarithms into one? Well, there are two logarithms added together, and so those condense into one logarithm. Unfortunately, you can't just add the x plus 24 plus the x. What happens to the x plus 24 and the x? You multiply. Yeah, you multiply these. When I have two logarithms added, to condense them to one, you multiply the two things you're taking the logarithm of together. Yeah, we can do that. That's one of the properties of logarithm. Condenses like that into one. You just have to multiply here, which doesn't seem at all right, but that's what happens, right? We looked at those properties last time. That's what happens. Now, what does that give me? Let's go ahead and multiply those. That would be x squared plus 24x. We can distribute. Aha, so now we have one logarithm. We can do our exponentiate both sides. Clearly here the base is 5, so 5 to the log base 5 of x squared plus 24x equals, got to do that in the same thing to that side too. Over here, looks bad, but those just cancel out. Just x squared plus 24x, isn't it? Equals 25. All right, now what can happen is we don't wind up with now a linear equation. This is a quadratic equation. How are we going to solve it? Yeah, we need to subtract 20. We need to make one side 0, so we can either factor or use the quadratic formula. If this one does factor, I think they usually give us, they're nice and they give us nice factoring ones, but you could use a quadratic formula on that, but you need one side 0 to solve that, either by factoring the quadratic formula. And this one, nicely, it's x and x. Minus 25 and 24 in the middle. That's 25 and 1. And the plus 25 and the 1 is minus, right? Well, so that gives me x plus 25 equals 0 then. So both of those equal to 0. Subtract 25, you got x is negative 25. Add the 1, that x is 1. And so this is where the checking pays off, because one of those actually doesn't work, does it? Which one?
The negative 25.
Negative 25 won't work, because if I plug in negative 25, well, either place I plug it in, but if it doesn't work in one of the places, that's enough. But it doesn't work in either one of those logarithms, does it? Why?
Because it makes it negative.
You got the log of a negative. This would be the log of negative 25, which is clearly the log of a negative. This would be the log of base 5 of negative 1, which is also the log of a negative. And we've already seen those aren't real. We're talking about real solutions here. That's not going to give us a real solution. So 1's okay, but negative 25 is not, so we reject it. 1's going to be okay, but not the negative 25. Okay? All right. About this one. Log base 4 of 5x plus 3 minus log base 4 x. It's over just a hair. Maybe squeeze in a third one over there. So log base 4 of 5x plus 3 minus log base 4 of x equals 3. All right, so we have the same problem. We've got two logarithms. We need just one logarithm, but the properties of logarithms will allow us to remedy that, because how would these then, since I've got log minus log, how would those be combined into one?
You divide them.
You divide the two, yeah. So you take the 5x plus 3 divided by the x. That's how those would condense into one. 2 logarithms subtracted condensed by dividing the inside parts. So now we're good. Base 4, so exponentiate both sides to base 4. This side would be this side would be 4 to the third. Yeah, base 4 both sides, basically. 4 log base 4 cancel. Just leave me 5x plus 3 over x equals 64. Yeah. So we have this nice little equation. Not the easiest equation ever, but not too bad. What can we do to solve that? Well, one thing we do, multiply both sides by x. And that'll cancel the x out there. So yeah, just multiply both sides by x. One way to think of it. Cross multiply if you want to. This side then will be 5x plus 3 equals 64x. That's just linear, so subtract the 5x. And then that's 59x divided by 59. So x is 3 over 59. Does that check out? I think so. 5, yeah, that's definitely going to be a positive number. 3 over 59, that's a positive number, so it's okay. Checks out. Good on that? All right, let me show you one more here. Finish off these logarithm equations that I wanted to show you. All right, so let's say we got log base 3 of 2x plus 50 equals log base 3 of x plus 1 plus 4. All right, so what do we do if we have logarithms on both sides like this? Well, like you said, we only need one logarithm in the equation. Unfortunately, both these one logarithms on either side. We've got a logarithm on either side. I need those to be on the same side, don't I? So how do I get that? Well, I just bring this one over by subtracting it, just like I would any other number or expression. To move, we've got 2 added together. Just subtract this one over. Basically. So let me just subtract it over. Let's write it this way. That's confusing, I think. Subtracting log base 3 of x plus 1 to both sides. So that's what I get. Just subtract it from both sides. That's what I get. Well, now it is like the one we have right here in the middle, isn't it? I've got 2 logarithms. They are subtracted, so those combine into one logarithm by dividing the inside parts. Now I can do the exponentiate. It's base 3, so exponentiate both sides to base 3. Log base 3, that equals 3 to the 4, right? Cancel the 3 to the log base 3 out, so you got 2x plus 50 over x plus 1 equals, that's 81. Very similar, like I said, to the previous one there. Solve that. One way to do it is just multiply both sides by x plus 1. That'll cancel the x plus 1 out, leaving 2x plus 50 on the left here. Now we do have the, you do have to distribute there. That 81 distributes, make it 81x plus 81. Not 81x plus 1, it's 81x plus 81, because it's times both of those. Yeah, similar, so subtract, let's go ahead and subtract 2x. And subtract 81. the x's on one side, the constants on the other, that's negative 31 equals 79x. So negative x is negative 31 over 79, which is about .392, approximately negative 0.392, 3 decimal places. It's a negative, sometimes that's alert, to just make sure it checks out. Is that going to be okay if I put negative 0.392 about there in those? Well, yeah, it's okay there, isn't it? A negative 0.392 plus 1, that gives me a positive number. It's okay. 2 times that plus 50, that's obviously going to be bigger than 0. That's okay. Is that all right? Good on that? All right.